This is Secondary 1 Honors, Quarter 4, video number 2. This video will be about adding vectors graphically. There are two methods that we can use to add vectors using a graphing idea, and they are called either head to tail or tip to tail. That's the same thing, so that's the first method. And then the second method is tail to tail. We'll be using both of these, and you'll have to show how to do these on your test. Okay, the first one is known as the head to tail, or also known as the tip to tail method. So what we've got here is we've got vector A, which is going, it's the orange one, it's going to the upper right, and then B is in the direction down on the right, and you can see that B is a little bit longer than A. So when we put them head to tail, as we saw in our last quarter's instructions briefly, you're going to just put the first one down first and then the second one right on top of it, end to end. So this one goes first, then that one, and so you have, that's why it's called tip to tail. When you do that, in order to get the sum, this right here, this is the resultant vector. Now the direction that you put that arrow is important. You cannot have it go the wrong direction, because since vectors show direction as well as magnitude, you can't have it going the wrong way. So the way that you can remember with adding, because it is different for subtracting, but the way you do with adding is you're going to start where you begin. So since you started right here to go that direction, that's where you start to draw your resultant vector. And when you do that, we would say that the sum vector is this right here. So that's actually your answer, is that resultant vector. So you have to do that. You cannot just do the two vectors together like that and say that's it. That's not your resultant vector. So you want to make sure that you show your sum resultant vector. Okay, let's try another one. Another way to do this is to use, we're still going to use head to tail, sorry, and we're just going to do another example. And so you just again put them down one end to end. So we're going to take the first one, and it's got to go the same direction and be the same length. So, and then you're going to put the second one down at the tip of the other one, and it's going to go in that direction. So it's going to look like this. So you see we have C, that's where we started, that's our beginning point, and then we're putting on top of that in the same direction that it should go as D. And then our resultant vector, we're going to start where we started right there and go to close that triangle, and that is our sum. So we would say that our resultant vector is that. Okay, the other method is tail to tail. It's also known as the parallelogram method, and you'll see why. We're going to actually make a parallelogram from our vectors. And so the first thing we're going to do is, again, taking the vectors in the same length and the same direction, we're going to put them down, but we're going to put them this time with the tail right there, that tip right there, together. Okay, so we're going to put them so they both are starting from that same initial point. So when we do that, we've got our two vectors here, as we can see. And then what you're going to do is you're going to create a parallelogram. And so the parallelogram, it's going to be at like the same slope. This is going to be parallel to that, and then this one is going to be parallel to this one. So you're making this parallelogram, and that's why it's called the parallelogram method. Now the way that we get our resultant vector is we are going to begin at this point where we put both of those vectors down, and we are going to draw a vector from that point to the corner opposite. So you're starting still at the beginning there, and you're drawing this vector opposite. That is your resultant vector. Now if we compare that to what we just did a minute ago with head to tail, if we were to do A and then B, head to tail, something like that, and if we start at the beginning, we're going to have the same vector, which makes sense that you have to have the same resultant if you're adding the same vector. So that vector should look the same as that, same length, same direction. Okay, so let's do an example. Number 3, use the head to tail method. So we're just going to take A, and we're going to draw it again. So draw it again, same direction, same length. And then you're going to take B in same direction, same length, but we're going to do head to tail. So we're going to start right here. We're going to go in the same direction, same length. And of course I'm having to approximate a little bit. And then what we're going to do is we're going to close that triangle. So you start at the beginning where you started there, and you're going to go that direction. Okay, so your resultant vector would be that. Okay, the next example, let's do tail to tail. And so we're going to take vector A, and we're going to put that down here, same direction, same length. Take vector B, and we're going to put these together like that. I want those to touch. It's hard to see from what I'm doing here. And then we are going to make a parallelogram. So I need something parallel to this red one, and then I need parallel to the orange one. And then what I'm going to do is I'm going to get my resultant vector. It's going to go like that. Now, it's a good idea to have a backup plan, and I like to do that in case I'm feeling a little bit unsure. I can try a different method. So if I was to take these exact same vectors and do head to tail, then my resultant vector is going to look, I don't think I did my links very good, but it's going to look roughly the same as it does. If I did this exactly right and was a little bit more careful, it would be a lot more similar. But that's how it should look. Okay, we are also going to use the same ideas, but we can use them on a grid. And so if we're given vectors in component form rather than in visual form, we can actually put these on a grid, and we can use the same methods. We can be a little bit more precise this way because we can use the grid to help us measure. So what we're going to do is we're going to take the first vector, we're going to do head to tail, and so just pick a place to start, and we're going to first do our components 2, 1, so over 2 and up 1, and that's going to be our first vector. And then we're going to get our second vector, negative 4, 3, and we're going to, since we're doing this head to tail, I'm going to start right here, and I'm going to go negative 4, and then up 3. And so this is my second vector. My resultant will be this vector right there. And so I'm going to label that as R, and that would be my answer. My component, the components of my resultant vector, if I'm going to write that, which you don't necessarily have to unless you're asked to, but remember that this is our initial point and our terminal point, so I'm going to go negative 2, positive 4. Okay, and that would be my resultant vector. You could check what you're doing by using the tail to tail. If you wanted to, you could go over 2 and up 1, and then you could go negative 4 and then up 3, and use your parallelogram. Okay, so I'm going to go that, and then my resultant vector, notice how it has the components of negative 2 and positive 4, so it should be the same thing. If it just says to use head to tail, you do not have to do both methods. You just have to show the one that it's being asked for, but you're welcome to double check it. Okay, let's do this one using tail to tail. So we will start, just find a place to start. We're going to do 2, 1. Once in a while you might pick a place to start and you might find out that you run out of space, and so you might have to erase it and go back and start somewhere different so that you don't run out of space. Since I'm doing tail to tail, that means I'm starting the other one at the same place I started, so their initial points will touch. So I'm going to start this one at negative 4 and positive 3. Okay, I just did this one on the other graph actually to check what I did, but we'll just do it where we have grid all to itself. And then there's my tail to tail method. So what we're wanting you to do is to be able to do either method and be able to get the same result either way and know which one is which. So negative 4, negative 2, pick a place to start. So negative 4, negative 2. And then since I'm doing head to tail, I'm going to start here and I'm going to go over 3 and down 1. Okay, then my resultant is starting here, going to my ending point, my terminal point, and that is my resultant vector. So in 6b, I'm going to do the exact same addition, but I'm going to do it tail to tail. So I should get the same thing I had. I'm just going to note my components. -1, so if I start here and I go here, I have -1, -3. So when I do it on 6b, I should get the same components. So starting somewhere else, this time it's going to be tail to tail, so I'm going to start at one place for both of them. So -4, -2, and then the second one is going to be +3, -1, so starting here, going over 3 and down 1. Okay, now you got to remember that you're doing a parallelogram here. You are not just closing the triangle. That means something very different, as we will see. So if you're doing tail to tail, you need to remember that you're using a parallelogram for that. So to make sure it's a parallelogram, I'm going to start right here and I go over 1, 2, 3 and down 1 so that it's parallel, same slope. And I close that, and then that will be my resultant vector. So then to double check and say my components, if I start here, I go -1, -3, which is what I had, so I'm comfortable with my answer. Okay, the next thing we're going to look at is if you have a picture of some vectors being added, can you tell which one is the resultant vector? If these vectors are being added tail to tail, if that was the case, then we would have to make a parallelogram and the resultant would be going across like that. So I can tell that it's not A plus C. If it was A plus C, the resultant would look different. If it was head to tail, it can't be C plus B because they're both going towards each other, and that's not going to be head to tail. And so if I look at this, I should be able to tell that I'm doing A plus B, and my resultant vector is C. So what I'm asking you to do is to write that the resultant vector is C. The equation to get there is vector A plus vector B equals vector C. Okay, so look at number 8. Now remember, you can't have them tail to tail unless you're going to be making a parallelogram out of that. So if I was making a parallelogram, my resultant vector would be going like that. So since that's not the case, then it can't be A plus B. Okay, so looking at what the other possibilities are, it can't be C plus A because they're both going in the same direction. That's not going to be head to tail. And so it's going to have to be B plus C, and my resultant vector will be A. So I'm going to write A as my resultant vector, vector B plus vector C equals vector A. Okay, you can now complete your worksheet, problems 5 through 15, and then you'll continue with video 3.